Hello everyone, welcome back to another video with Mr. Coder. And in today's video, I'm going to show you how to solve Goblin, question F from Codeforces Round 1020, Division 3. So this is similar, it's connected to question A in the Dr. TC's board that has n binary strings. So if you want further explanation on that, of how that actually works, go check out that video since that's where I actually go more in depth, since that's the bigger part of the problem. But in this, I'm just gonna skim over it a little. So, uh, so basically, he has a binary string A and then n binary strings S1 through Sn, and you flip the ith character of the ith string, which means 1 flips to 0, 0 flips to 1, and then the first string will be written at the top of the board, and each other string will be placed uh straight below the previous one, which will create a grid of n rows and n columns. So then a set S of cells of G is considered good if the value of every cell in S is 0, and for any two cells A and B in S, B is reachable but from A by a sequence of adjacent cells that all have the value of 0. So Goblin's task is to find the maximum possible size of a good set. So for this problem, notice that n is less or equal to 2 times 10 to the fifth. So unlike question A, where n is less or equal to 100, where you can literally create the matrix, and then this problem you can do what, like flood fill or whatever BFS you want to do, or DFS. They both work if you had n is less than or equal to 100 or whatever, then it would work. But now it's n is less than or equal to 2 times 10 to the fifth, which shows that n squared won't work. So how do you do it, you may ask? Well, let's just check the samples to see how we can look at it from here. So the first one, 0, 0, 0. So it'd just be flip the first one, second one, third one. So then you get this. And what is the maximum connected? Well, here's 3, 1, 2, 3, and here's another 3. So the maximum is 3. So as you can see down here, from this 0, 0, 1, 0, you keep flipping this one, this one, this one, and this one. And then you end up getting uh this huge chain of zeros. And this one isn't connected though, but all the others are. So there's these 5 and then 9. So that's why the answer is 9 here. So that's basically, so now you can see how the problem of course works. But that, of course, if knowing how the problem works, that's the easy part. You need to know how to solve the problem. So how can you solve the problem without actually making the matrix? So, I mean, if when you look at this array, does it look like there's any pattern to you? Well, maybe not really, because it's hard to even find the string A from this unless you actually know what the transition is. So that won't work. But what's another thing that remains consistent? So if you notice in each column, there's only going to be one different number. So in this case, they're all 0 except for this one, since it's the same ith string, ith character. So then notice that this column too. Notice that this one is different, then in this case this one's different and this one's different. So notice that I'll clear it up to make it a little easier for you to see. So this one, this one, this one, and this one. So those are the 4 that are actually changed, but otherwise all the columns are the same. So then a thing we can notice is we can use DSU, disjoint set union, so then we can connect the sizes. So it's a standard to connect like the sizes, which is the value of each set. So something we can notice is there's only a certain amount of groups actually. Like notice that here's a group. This is one group right here. This is another group, and there's none above. This is a group, then it's split up by this one, and then this is the rest of the group. So then this is splitting up this group and this group. So notice that, like, except for the first and the last one, where there's only 2, the rest have 3 groups. The one above the switching mark where I equals I, the then the switching mark itself, and then the rest of them below. So that's when you notice that, oh, there's only 3n. There's only 3n different groups that it could actually be in. And that's a lot easier. That's actually calculatable with the given n's less than or equal to 2 times 10 to the fifth right here. So then, since that would just be 6 times 10 to the fifth, which is easily storable in memory, especially in C++, where it's a lot better. So that's really how you can calculate this. This problem isn't easy. There's many different ways to do this, but they all come down to some sort of thing where you check through the columns. And the reason why this problem's actually a problem where you need to think about it more is because it's not obvious. Like if this was rows, like if this column was a row, it'd be a lot easier to see. But since us humans, since we read from left to right. So looking at it from left to right, there doesn't seem to be any pattern. But if you look at it from columns, you notice that there's only one different. And although that might seem obvious, that's actually the key observation to solve the problem. So now going to my code here, this is basically just classic DSU. The only thing is instead of just having a parent, as I sometimes do when I'm speed coding, you really have to you also have to adjust the sizes. And you also have to make sure that if parent of y is equal to x, then you update size of x. And also, sometimes you don't include this, but if x is equal to y, you return, so then the size isn't duplicated. And this find is just like any normal find. There's only parent included in it. So that now for the actual solving the problem. So notice how I made the DSU functions 3 by n. And as you can see here, that's because it's anything above, then anything in the middle, which is the reason why it can't be one group, and then anything below. So that's why there's 3 times n groups. And then you go through the n things, and then that's just to start creating the sizes. So as I commented here, there's I above, and then n minus I minus 1 below. So this basically is just to notice. And the reason how I was able to come up with this is just if you think about it for the first row, it would just be the first column, it would just be this one, then there's only gonna be 0 above if I is equal to 0. So then, and how do I get n minus I minus 1? Well, if there's 0 here, then there would have to be uh n minus 1 below, because then there's 1 in between. So then I had if the current one's equal to 0, then that means that I have to then that size actually matters. If it's equal to 1, then it doesn't matter since you can't connect it at all. So then size of I is equal to I, that's the above. Size of I plus n is equal to n minus I minus 1, that's below. And then the size of I plus n, which is the middle area, is 0 because you cannot connect it. Otherwise, then the middle actually is 0. So then you can, or that it will turn into 0. So then you actually change it to 1. And then the rest of the code is just uniting all of the parts of the DSU. So this is basically just horizontal, vertical, and all the different types of connections. So I'll go through very quickly. So I and I plus 1, that's just horizontal connections. So for example here, this column and this column, they would be connected because they're in adjacent rows. And then this same here. So this is basically horizontal connections. This one is I and I plus n plus n and I plus n and I plus n plus n. That's basically connecting this vertical, for example, this vertical one right here to this one. And then you'd also have one for horizontal as well. Well, this one like that too. And then similar for this one too. This one has a lot more conditions, but you do I plus n plus n and I plus 1, then I plus n minus 1. So that's basically just to connect it to any other ones. So this basically is just you calculate all the different possible connections. So like this 0 right here, it's a separator, so it can connect to this side and this side. And any row can also connect to like any other row. So that's basically how you connect it. And then of course the DSU handles the size. And then you just get the maximum of the size array and just print it out. So for any tips of this problem, you just need to think of what stays the same. Like you notice here, each column, well, there's three, which is n minus one of one kind and one of the other, because you switch that one spot. So notice that then you could just have 3n, which is a lot easier to handle with than n squared, which you can't actually store. So that's something that like remains the same throughout like a large n, is that there's always going to be 3n groups. So that's the key observation that helps you solve this problem, Goblin. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.